From the demonstration of how root from script.optimze works, we have a working sample code that we can now change into code solving exercise 5.7. Let's save our code under a different file name and then copy our plain text pseudocode that we prepared in a separate video and paste the pseudocode in as a comment at the bottom of our code. We can now piece by piece copy our pseudocode to places where we need it and translate it into Python code. The residual equations should be at the end of our function. So we just need to change the text residual 1 to res bracket 0, etc. and delete the previous code. We see that we get a lot of errors here telling us that we have undefined variables, but that's fine as we haven't copied everything yet. For one thing, we haven't changed our interpretation of the variable guess. So let's copy our list of unknown and change that. We are also lacking all of our dependent variables that we need to calculate inside our routine. We need them before we calculate the residuals, so let's paste them in as a comment before the calculation of residuals. To calculate them, we need the other functions we listed. Let's paste them in. From the videos explaining how to use them, we know, for example, that we are only interested in the first output from hsteam and that we can ignore the others by writing comma underscore, comma underscore. For the steam enthalpy Hs, the condensation temperature is Ts, and we can have the second argument as -1 since the steam is not overheated. For Hv, we can have the arguments T and -1 since we are currently ignoring boiling point elevation. So that's Hs and Hv done. The routine HL gelatin, we need to calculate HF, HL and HK. So let's make 3 copies. For HF, the arguments should be XF and TF. For HL, it should be XL and T. And finally for HK, it should be 0 as the weight fraction and Ts as the temperature. That's HF, HL and HK done. The only dependent variable left to calculate are now Ts and T. For T we use the pressure P and for Ts the pressure PS. That's all the dependent variables done. Let's turn to the known variables. We replace our previous A and B with our known values, turning the units into comments. Let's reflect on the units. The pressure should be in Pascal rather than kilopascal, so let's change that. Now we have specified all our values, but we also need to put them into the tuplet other arguments. Thus we copy our list of known variables from our pseudocode and replace A and B with our new list. The guesses are currently not good. We now have 4 unknowns, S, V, L and A, and we may want to use more intelligent guesses. As S, V and L are all flows that are likely to be of the same order of magnitude as F, let's use F as our guess for them and let's use 100 as the guess for the area. We're almost done, but we have some lingering errors. Let's see, undefined name HK. Well, that's because I misspelled HK a few lines up. Let's correct that. Undefined name T. Well, that's because we need to calculate T and Ts before we use them. So let's move those calculations up so they appear before being used. Now all errors seem to have disappeared. Let's try to run our code and see what happens. We get a runtime type error. Our function takes 3 positional arguments, but 8 were given. That's because I forgot to change the definition of our function. It still says A and B, where all our known variables should be listed. So let's copy the order from the tuplet or other arguments and paste it over A and B in our function definition. Now when we run our code, it all seems to work and we get the area as 15.9 square meters, which is in agreement with our calculations by hand. Let's check what the residuals become for this solution by printing the result of calling our function with the solution sol.x. To transfer the tuplet other arguments into a simple list of arguments, you can type a star before the variable name. When we run the code now, we see that the residuals become really tiny. Let's try to break our code by making a deliberate mistake in the calculation of residuals. Let's replace res2 with res0. We now get the message that the iteration is not making good progress, and we see from our test printout that one value of the residuals is -1. After attempts to break our code, don't forget to change back, or even better, save a copy of your code before you try to break it. In the code we provide through the course web, we might have made slightly more fancy printouts and perhaps added a comment or two.